Hi, so now I am going to explain the logic or gates. I already have a video about the AND gate, and this one is similar. The only difference between the big difference between the AND gate and the OR gate is here the transistors are going to be in parallel. So in this way, um, if one of them is receiving current, then the LED is going to be on. This means that if we only need one of the two conditions, for example, we only need one of the two conditions to be satisfied, and in the AND gate case, both conditions have to be satisfied. So this is the big difference, and for that reason here the logic truth table also is different. I make a circuit diagram so it could be easy for us to understand this process. First, as in the other one, we need to connect the ground and the 5 volts. Okay, so ground is going to be in the minus and the plus in the one with the 5 volts. So okay, also as in the other one, we are going to start with a resistor. Okay, we only need to be the resistors to be connected to the 5 volts, to the line of the 5 volts. Okay, and also now we're going to use our transistors. Remember that this one is a collector, base, and emitter. The collector is going to be the collector is going to be in the same line as the resistance. Also the resistance is of 1 kilo ohm, and now we are proceeding to put these two transistors in parallel connection. So in this way, only one of them has to be satisfied in order to the LED to be on. Okay, so I am going to put my transistor here. As you can see, this one is a collector, base, and emitter. The collector is connected in the same as the resistance, and both. Okay, and also I am going to put my other resistance here. I am putting in this way so it could be more clear, but this way, this one has to be connected as the same as this one, so both collectors are connected to the same line as here, so this can be parallel. And also we are going to connect now our LED. Remember again that I am going to use now a LED red. Remember that the shorter leg has to be in the ground, so this line is the ground line, so I am going to connect the ground here, and this one has to be connected to the one that is the emitter. But also remember that this emitter has to have a connection to this LED, so this can be a parallel connection. So we have to connect. I am going to connect this one to this one, and now this one is a parallel connection of these two transistors. We have our resistor and our LED as in this circuit diagram, but as we can see, this one is a 0, 0, 0 because in both the current is flowing through here, but the current is flowing through here, but here the current can float. So, and also here. So in order to make the current flow, we have to make a connection between here and the base, because as we explained in the other video, a transistor, in order for the current to flow and to pass, it has to come from the base, because if it comes from the collector, it can flow, it can pass, and it's like the current is only going to be collected right here. So here in this example, we don't have any connection. So we have to make some connections. In this example, we are seeing this 0, 0, 0. Now we can do a 0, 1, and we're going to see that the LED is going to be on. Remember that if we see a 1 in this column, this means that this one is going to be on and this one is off. Okay, so now we are going to make a connection. We have to connect the one from the current is coming from here, from this line. We are going, and then to the base. So now the base can receive, and maybe you can see it because of the, oh my god, we forget something important. or it need to be our power source. So in the another example, we can see here is off, and now I'm going to put right now the connections through the base, and one of them, we can see that one of them is receiving this connection. For example, this one, we are making these connections and the current is coming through the base, and then the current is flowing, right? Also the resistance in, okay, yeah, and the current is flowing, so the LED is going to be on. If we make the other connection, oh well, if we change this connection, for example, now here, this one is going to be the only one that is going to be connected, right? The LED is on too, because this is a logic OR gate. If one of them is connects, then the LED is going to be on. It's not necessary for both to be satisfied, only one of them. And now we are going to see the example if both of them are connected, because this one is the example of 1, 1, 1, and well, also the LED is on. So in this one, both can be connected. Also both conditions. For example, we can see that the transistor has conditions or switch. If both conditions are satisfied, then the LED is going to be on. If one of them is satisfied, also the LED is going to be on. So yeah, I hope that you understand the logic OR gate. It's pretty similar to the AND gate, and I hope that you like the video. Thank you for your attention, and